Real images of what NASA found on freckled moon Europa. Jupiter's moon Europa is beautiful. Have you ever seen it? Here it is. This is not an artist concept. This isn't an illustration. This amazing picture is showing the fascinating surface of Jupiter's icy moon as seen by the Galileo orbiter in the 1990s. This is the color view of Europa that shows the largest portion of the moon's surface at the highest resolution. Color variations across the surface are associated with differences in geologic feature type and location. For example, colors help us to distinguish areas containing water ice from the ones which include non-ice components. We will talk about it later on in this video. I would invite you to take a seat and take a deep breath, because we're about to dive into this fantastic world. Are you ready? Let's go. First, 3 young women who were captured by Jupiter for the secret love shall be honored, including Europa, the daughter of Agenor. The second moon is called by me Europa. Io, Europa, the boy Ganymede, and Callisto greatly pleased lustful Jupiter. This was written by Simon Morius in 1614 in his famous Mundus Iovialis. Simon Morius was a German astronomer, pupil of Tycho Brahe and Kepler. In Mundus Iovialis, he described the planet Jupiter and its moons. He was in dispute with Galileo because he claimed to have discovered the 4 major moons a few days before Galileo. Today, we think that it is possible that Morius discovered the moons of Jupiter independently of Galileo, but at least a few days after the Italian. Whatever the exact order of the events, the mythological names of the 4 moons used today, Io, Europa, Ganymede, and Callisto, are those given to them by Morius. Europa in Greek mythology was the princess of Tyre and queen of Creta. The first time humanity observed Europa was with Galileo. In 1610, the famous scientist pointed his telescope towards Jupiter and discovered the 4 Galilean satellites, which are known today as Io, Europa, Callisto, and Ganymede. It's hard to say which one of them is the most fascinating moon. One could think about Io, the hellish world, or to Ganymede with its huge water ocean underneath the frost. But Europa, this ball of silicate rock and water ice, is amazing. Just take a look at this picture. It shows the 4 Galilean moons from left to right, starting from Io and ending with Callisto. New Horizons spacecraft had the honor to capture these pictures, and NASA put them together in a single family portrait of Jupiter's moons. As you can clearly see, Europa is the smallest of them. It is 3,120 kilometers in diameter, and New Horizons took this picture from a distance of about 3 million kilometers. If you look closely, you can notice that Europa's surface is different from the surface of other moons. It is an icy, smooth surface that likely conceals an ocean of liquid water. Why is it so smooth? It seems craters are almost absent on Europa's surface. While Europa is actually the smoothest known object in the solar system, it lacks large-scale features such as mountains and craters. Considering that Europa is constantly hit by cometary bombardment, we explain this smoothness by saying that the surface is really young, with an estimated age which is about 20 to 180 million years old. This finally means that the surface is constantly and rapidly changing. However, does this mean that Europa's surface is boring? It is a surface without any features to note. Well, that's not exactly so. Scientists think, for example, that Europa's equator may be covered with ice in an unusual way. Imagine polar regions on Earth. It has nothing to do with them. According to one study, instead, icy spikes called penitents are covering the moon equator. They could be up to 15 meters high and vertical. Unluckily, we don't have pictures of these unusual features, but radar and thermal data are consistent with this interpretation. Also, as you can see from this picture taken by the Galileo orbiter spacecraft, Europa has freckles. These reddish spots and shallow pits pepper the enigmatic ridge surface of Europa. Each of them is about 100 kilometers across. The dark spots are called lenticulae, the Latin term for freckles. Their similar sizes and spacing suggest that Europa's icy shell may be churning away like a lava lamp, with warmer ice moving upward from the bottom of the ice shell, while colder ice near the surface sinks downward. As we can read on the NASA website, surface features indicate that Europa could host life. Europa's surface has very few craters, indicating that recent or current geologic activity has removed the traces of older impacts. The paucity of craters, coupled with other evidence, has led scientists to surmise that there could be an ocean of liquid water beneath Europa's surface. Where there is water, there could be life. This is why Europa is a target of current interest for the study of the possibility of non-Earth life. A follow-up spacecraft to Galileo will be Europa Orbiter, which should determine whether or not Europa has an ocean. Europa orbits Jupiter in 3.5 days at a distance from it of about 670,900 kilometers. Its orbit eccentricity is very small, with a value of only 0.009, which means that the orbit itself is nearly circular. Europa is being pulled and stretched by Jupiter and other nearby moons. As it comes slightly nearer to Jupiter, the gaseous planet gravitational attraction increases, causing Europa to elongate toward and away from it. As Europa moves slightly away from Jupiter, Jupiter's gravitational force decreases, causing it to relax back into a more spherical shape. This creates tides in its ocean. This tidal flexing gives Europa a source of heat, possibly allowing its ocean to stay liquid. However, Europa's most striking surface features are a series of dark streaks crisscrossing the entire globe called linea. These linea suggest that Europa's surface could host volcanoes. This image, taken by the Galileo orbiter, shows features that may flow from ice volcanoes. It was taken by the Galileo system during its 7th orbit around Jupiter. The sun is illuminating the scene from the left. On the northwest corner of the image, one can see features with shapes similar to lava flows on Earth. The southern feature instead appears to have flowed over a ridge along its western edge. This beautiful picture clearly shows the presence of linea. Color variations across the surface are associated with differences in geologic feature type and location. For example, areas that appear blue or white contain relatively pure water ice, while reddish and brownish areas include non-ice components in higher concentrations. The polar regions visible at the left and right of this view are noticeably bluer than the more equatorial latitudes, which look more white. This color variation is thought to be due to differences in ice grain size in the two locations. Okay, now we know a lot about the surface. What about the internal structure? Before finding out the answer to the question, be sure to like or dislike the video so that we can continue to improve and make these videos better for you, the viewer. Plus, be sure to subscribe to the channel, clicking the bell, so that you don't miss any of our weekly videos. As we've already said, it is estimated that Europa has an outer layer of water around 100 kilometers thick. Underneath a crust of ice, there might be an ocean of liquid water. Also, in order to understand what lies in the deepest layers, astrophysicists studied Europa's magnetic field. Recent magnetic field data show that Europa has an induced magnetic field through interaction with Jupiter, which suggests the presence of a subsurface conductive layer, thus reinforcing the liquid water hypothesis. Europa is also likely to contain a metallic iron core. One interesting thing about Europa is that you could die if you were exposed to its radiation. The radiation level at the surface of Europa is equivalent to a dose of about 5,400 millisievert per day, an amount of radiation that would cause severe illness or death in human beings exposed for a single Earth day. The duration of a Europan day is approximately 3.5 times that of a day on Earth, resulting in 3.5 times bigger radiation exposure. Exploration of Europa began with the Jupiter flybys of Pioneer 10 and 11 in the 70s. The first close-up photos were of very poor resolution compared to later missions. Here's how Europa looked like to the eyes of the Pioneer 10 spacecraft. Then in 1979, it was the time for the two Voyager probes. They traveled through the Jovian system, providing more detailed images of Europa's icy surface. It was with the Voyager mission that scientists started to speculate about the possibility of a liquid ocean underneath. Here are some pictures taken by the Voyager probes. But this was not the end. In the 90s, NASA decided to understand better Jupiter and its moons, as well as the asteroids Gaspra and Ide. So they decided to launch a probe, the Galileo probe. Galileo arrived on Jupiter in 1995 after gravitational assist flybys of Venus and Earth, and became the first spacecraft to orbit Jupiter. Good job, Galileo. The vast majority of the images we showed you so far were in fact taken by the Galileo spacecraft. But I want to show you an incredible collage. The mosaic on the right of the south polar region of Jupiter's moon Europa shows the northern 290 kilometers of a strike-slip fault named Astroplenia Linea. The entire fault is about 810 kilometers long, the size of the California portion of the San Andreas Fault on Earth, which runs from the California-Mexico border north to the San Francisco Bay. The left mosaic shows the portion of the San Andreas Fault near California's San Francisco Bay that has been scaled to the same size and resolution as the Europa image. Each covers an area of approximately 170 by 193 kilometers. The red line marks the once active central crack of the European Fault right and the line of the San Andreas Fault left. They look very similar, don't they? The only difference is the mechanisms that produce them. As for Europa, fault motion is induced by tidal forces and gravitational tug from Jupiter. Here on Earth, large strike-slip faults such as the San Andreas are set in motion not by tidal pull, but by plate tectonic forces from the planet's mantle. What about future missions on Europa? Conjectures regarding extraterrestrial life have ensured a high profile for Europa and have led to steady lobbying for future missions, so I think we will hear soon some news coming from this distant moon. In particular, we will have Jupiter Icy Moon Explorer JUICE, which will include 2 flybys of Europa, even though it will be more focused on Ganymede. Another important mission in the program is Europa Clipper. Its aim is to explore Europa to investigate its habitability and select sites for a future lander. Imagine how amazing it would be to find that there's life on a moon in the solar system. The only thing we can do is wait, and meanwhile, keep it curious. That's all for this video. Thanks for watching, everyone. Are you guys in love with Europa? Let us know in the comments below. See you soon on the channel.